why the Great Repeller is more terrifying than the Great Attractor. What if the most powerful force shaping our galaxy isn't something out there, but something missing? Right now, our entire galaxy is racing through space at over 2 million kilometers per hour towards something we can't even see. But scientists may have found something even more disturbing. Not a monster pulling galaxies in, but an empty region of space pushing them away. Everyone talks about the Great Attractor, the mysterious force dragging galaxies across the universe. But hidden in the cosmic web is something stranger, the Great Repeller. It isn't a black hole. It isn't a massive galaxy cluster. It's almost nothing at all, and that's what makes it terrifying. 1. The cosmic monster everyone talks about. For decades, astronomers have been obsessed with a mysterious region of space known as the Great Attractor. Hidden behind the dense stars and dust of the Milky Way, this enormous gravitational anomaly appears to be pulling entire galaxies toward it. Not just a few galaxies, hundreds of thousands of them, including our own Milky Way. Every second, our galaxy is hurtling through space at over 2 million kilometers per hour towards something we cannot directly see. Naturally, this sounds terrifying. A giant unseen force dragging galaxies across the universe. But what if I told you there's something even stranger? Something many astronomers consider even more disturbing than the Great Attractor itself. A mysterious region called the Great Repeller. And unlike the Great Attractor, which pulls, the Great Repeller seems to do something that shouldn't even make sense. 2. The discovery that broke expectations. For years, astronomers believed they understood why galaxies moved the way they did. Gravity pulls matter together. Massive structures attract smaller structures. Simple. Then researchers began mapping the motions of thousands of galaxies in unprecedented detail. What they discovered was deeply unsettling. The movements didn't completely match existing models. Yes, galaxies were moving toward the Great Attractor, but something else appeared to be influencing their motion as well. It was almost as if galaxies were simultaneously being pushed away from another region of space. The data seemed impossible. Gravity attracts, it doesn't repel. Yet the observations continued pointing toward the same conclusion. Somewhere in the universe existed a vast region, exerting an influence that looked remarkably like cosmic repulsion. 3. The universe's giant empty hole. The Great Repeller isn't a giant object. It isn't a massive galaxy cluster. It isn't a supermassive black hole. In fact, it's almost the opposite. The Great Repeller appears to be associated with an enormous cosmic void, a region containing far less matter than expected. At first glance, that doesn't sound frightening. Empty space sounds harmless. But on cosmic scales, emptiness can become surprisingly powerful. Imagine a crowded room where everyone suddenly runs toward one side. From the perspective of someone inside, it feels as though the opposite side is pushing people away. That's essentially what's happening on a galactic scale. The Great Repeller may not be actively pushing galaxies. Instead, its enormous lack of matter creates an imbalance that causes galaxies to flow away from it. 4. Why emptiness can control galaxies. One of the strangest lessons in modern cosmology is that empty space isn't really empty. The universe is shaped not only by what exists, but also by what doesn't. Massive galaxy clusters pull matter toward vast cosmic voids, contribute by lacking that pull. Over billions of years, these differences create enormous rivers of galactic motion. The Great Repeller appears to sit inside one of the largest underdense regions ever identified. It's so empty that entire groups of galaxies are effectively moving away from it, not because they're being actively repelled, but because every surrounding region contains more matter and therefore exerts stronger gravitational attraction. 5. The scale is beyond comprehension. The Great Repeller isn't influencing a few nearby galaxies. Its effects extend across hundreds of millions of light years. To understand how absurdly large that is, consider that light, the fastest thing in the universe, would require hundreds of millions of years to cross the structures involved. Entire galaxy clusters, each containing thousands of galaxies, participate in these enormous cosmic flows. The distances are so vast that human intuition completely breaks down. We struggle to imagine a city. We struggle to imagine a planet. The Great Repeller operates on scales involving entire regions of the observable universe. 6. Why scientists couldn't find it. The Great Attractor gained attention because it appeared associated with a concentration of mass. But identifying the Great Repeller proved far more difficult. How do you find something that's defined by absence? Astronomers weren't looking for a giant empty region. They were searching for mass. It wasn't until researchers mapped galaxy motions with extraordinary precision that the hidden structure revealed itself. The discovery was like solving a crime by identifying who wasn't present rather than who was. Instead of finding an object, scientists found a missing piece of the cosmic puzzle. 7. The Great Attractor may not be the real story. For years, the Great Attractor dominated discussions about large-scale cosmic motion. It was presented as the mysterious force controlling the movement of nearby galaxies. Then, the Great Repeller complicated everything. Researchers realized that focusing only on attraction painted an incomplete picture. Imagine trying to understand ocean currents while ignoring the shape of the coastline. That's essentially what astronomers had been doing. The Great Repeller revealed that cosmic motion results from a combination of both gravitational attraction and the absence of attraction elsewhere. Suddenly, the universe looked more complex than ever. 8. A universe built like Swiss cheese. As scientists mapped more of the cosmos, a surprising pattern emerged. The universe doesn't resemble a uniform distribution of galaxies. Instead, it looks more like a giant cosmic web. Dense filaments of galaxies stretch across space, while enormous voids occupy the regions between them. Some astronomers compare the structure to Swiss cheese, with galaxies forming around vast empty holes. The Great Repeller is one of the most dramatic examples of this architecture. It highlights a disturbing reality. Much of the universe isn't filled with stars and galaxies. It's dominated by enormous regions of near emptiness. 9. The frightening implication. What makes the Great Repeller truly unsettling isn't what it is. It's what it suggests. If giant voids can influence the movement of galaxies across hundreds of millions of light years, how many more structures remain undiscovered? The observable universe contains trillions of galaxies spread across unimaginable distances. Humanity has mapped only a fraction of this vast territory in detail. Every new survey reveals structures larger than previously imagined. The Great Repeller reminds us that some of the most important forces shaping the cosmos may be things we cannot easily see. 10. The universe is stranger than we thought. Throughout history, astronomy has repeatedly humbled humanity. We thought Earth was the center of everything. It wasn't. We thought our galaxy was the universe. It wasn't. We thought gravity alone could explain cosmic motions. If this mystery pulled you deeper into the darkness, like this video, subscribe to Cosmic Unknowns and stay with us because the next cosmic mystery may be even stranger. In the universe, sometimes the scariest thing isn't what's hiding out there. It's what isn't there at all. If you found this helpful, hit like and subscribe for more content like this.